So still on the theorem, we have considered the first theorem, shifting theorem. This theorem is talking about when you are given a function and the function is being multiplied by exponential. The second theorem is talking about when you are finding Laplace transform, that you are multiplying a function by t, or let's say t raised to power n. Now, 1. Let's say Laplace transform of f of t is equal to f of s, as we have said the other time. If you want to find Laplace transform of t times f of t, that is, it is no more exponential now. If it is t that is multiplying exponential, the formula is d ds f of s. What does this thing mean? It means I should differentiate. I'll put minus, then I'll differentiate the Laplace transform that we'll find. I'll differentiate it once. That is meaning of this ds. If it is twice, that is, if it is 2, if it is t squared that is multiplying f of t, this will be d squared over ds squared into f of s. That is, if you have found Laplace transform of f of s and you are multiplying that f of t by t squared, it means you should differentiate this twice. That is meaning of d squared ds squared. You differentiate. So this is where differentiation comes in. So generally we can have it like this: t raised to power n f of t. When you have it like this, generally we have minus 1 raised to power n dn ds raised to power n f of s. So we may not bother you on this, but you must take note of these two. When you are multiplying by t, it is minus differentiation of that function. Let's quickly take an example there. Let's assume that we want to find Laplace transform of t exponential 2t. This is a Laplace transform we are talking. This is a function we are talking about. You first know the Laplace transform of that function. If you know the Laplace transform of that function, which is Laplace transform of 2t, you know it is 1 over s. If you use the table of Laplace transform again, you need to rewind, go to the first one or the second one. You know, this is 2 there, it will be s minus 2. Therefore, what Laplace transform of t exponential 2t will give me will now be, according to this formula, I will say minus d ds 1 over s minus 2. That is, I will differentiate this. This is why I say you should go and learn how to differentiate. If I differentiate this thing now, I'm going to have minus 1 over s minus 2 squared. So minus times minus will give me 1, plus. That will be 1 over s minus 2 squared. So you should go and learn this simple differentiation. How do you differentiate this? You can use it like this: s minus 2. This 1 over s minus 2 is the same thing as s minus 2 raised to power minus 1. According to the way we normally differentiate, what do? We bring down this power to the back. That will be minus. We subtract the power by 1 again, minus 1 as usual. This will be minus s minus 2 minus 1 minus 1. That is minus 2. Then according to indices, anytime power has minus, you know it will be this division. So that's how we have minus 1 over s squared. So this is our answer. And if you want to use the shifting theorem, the first one that we did, you know, Laplace transform of t. If you remember that one, I'll first find Laplace transform of t. This is 1 factorial over s raised to power 1 plus 1 So this is 1 over s squared. That is for, if you are now using that first theorem, Laplace transform of exponential t will be equal to, this is 2t. It will, anywhere I see s, I'll turn it to s minus 2. So this thing will now become 1 over, instead of this s, it will be s minus 2 all squared. You see that it agrees, they are the same thing. It agrees with this theorem. Let's take another example. We want to find the Laplace transform of t cos 3t. So this is the function. So what's the first thing to find? We must first find Laplace transform of that function, which is cos 3t. And if you find the Laplace transform of that function, if you remember, if it is cos, s must start on top, s squared. Since it's trigonometry, I'll put plus. Then, and 3 squared. This is s over s squared plus 9. Now, therefore, Laplace transform of t cos 3t will now be equal to negative of the differentiation. If you remember the formula, minus differentiation of that, this is minus d ds into s over s squared plus 9. I can now use differentiation. When differentiation is having division, you should know that we have to make use of what we call quotient rule. So we say u is equal to s, v is equal to s squared plus 9. I don't need to be doing this. So du ds, if I differentiate s, I will have 1. dv ds, if I differentiate this, I will have 2s. So my answer will now be, let me bring the minus. So you can still call the formula for quotient rule. That is v du minus du ds minus u dv ds over v squared. So this is our v. This is our v here, s squared plus 9 times the u ds. This is our du ds, which is 1, minus u. This is our u, s into dv ds. This is our dv ds, 2s over v squared. This is our v squared, s squared plus 9 all squared. This is negative into, if you expand it, this will be s squared plus 9 minus s times this, we have minus 2s squared over s squared plus 9 all squared. This is minus into s squared, this is 9 minus s squared minus 2s squared. That will be minus s squared over s squared plus 9 all squared. So when this minus comes to this place, it will turn this minus to plus. So it will be plus s squared there. Then minus 9 over s squared plus 9 all squared. So that is that about that. And suppose it is t squared that is here. We only need to differentiate this thing twice. As we are differentiated this once, we need to differentiate it once again. So that is that about that. Let me give you something related to that. Let's say we are giving t raised to power 2 exponential minus 3t. This is a given function. I'll first find its Laplace transform. And Laplace transform of exponential is 1 over s. This minus will be plus 3. 1 over s plus 3. Therefore, Laplace transform of t squared exponential minus 3t will now be second derivative d squared dx squared. Since we have t squared there, into this. I'll first differentiate once. If I differentiate once, it will remain, this is d squared. It will remain 1, d ds. I'll differentiate this thing. If I differentiate it, remember I told you the other time, this one, let me look for a plain sheet. 1 over s plus 3, that is what we have. Take it to be s plus 3 raised to power minus 1. If you differentiate once, we have minus 1 into s plus 3 raised to power minus 2. So if I differentiate it, I will have minus 1 into s plus 3 raised to power minus 2. I'll differentiate it once again. If I differentiate it once again, minus 2 will come down to this minus 1 to become 2. S plus 3 raised to power minus 3. You know it is minus 1 minus 1. You know normally when we are differentiating, we normally put minus 1 there. So minus 2 minus 1 will give me minus 3. Here, it was formerly minus 1. Then minus 1 gives me minus 2 here. So finally, our answer is 2 over s plus 3 all cubed. So that is that about that. Now, let's consider another theorem. Now, Laplace transform. When the function is dividing t, and we are finding its Laplace transform, something of this nature, f of t over t. So the theorem states the following. The theorem states this: if f of t divided by t, we have considered when the function is being multiplied by t. Now is when the function is being divided by t. The theorem says if f of t over t has a limit as t tends to 0, that is, if you can find the limit as t tends to 0, and if the Laplace transform of this f of t is equal to f of s, then Laplace transform of f of t over t is equal to integral s to infinity f of s ds. So what matters here is how to find the Laplace transform of that f of t. So this one leads to integration. Let's take example. Let's assume that we want to find the Laplace transform of sine t over t. Here, Laplace transform of sine t, you must first know Laplace transform of sine t, because that is a given function. The Laplace transform of sine t, sine t is same thing as sine 1t. So what is there is 1. According to the formula, sine at is a, whatever that is there, is 1 over s squared plus 1 squared, which is still 1. Now, since we have known that, according to this formula, the first thing is we know that the limit of this thing exists. Therefore, Laplace transform of sine t over t, according to this formula, it will be integral s to infinity f of s. F of s is the Laplace transform of that function that we find. This one, the one you found there, s squared plus 1 ds. So this is very simple in integration. It's just the formula. So when we integrate this, it will give me arctan s to infinity. So what do we now have there? We have, if we integrate this thing, to give me arctan s, then s to infinity. What we have is, we first put s to be infinity, minus we put s to be s, arctan s. But arctan infinity is pi over 2. Remember, pi over 2 is same thing as 90 degrees. So arctan infinity is pi over 2, which is same thing as 90 degrees, minus arctan s. So this is our answer. Or we can continue if you want to apply trig identity. So we can continue, because this thing will still give me arctan s. To give me arctan s, in fact, I can still turn this thing to tan. It will be arctan 1 over s, still the same thing. But if it is this one you like, or this is still an answer. Now let's consider another example. Now what we are given here is Laplace transform of 1 minus cos 2t over t. The given function is the one on top. I must first find the Laplace transform of 1 minus cos 2t. Laplace transform of 1, that is the first thing. I will use this formula, which says Laplace transform of A is A over S. So therefore, Laplace transform of 1 is 1 over S minus cos 2t. When it is cos, S must be on top first, over S squared plus, what is there? 2 squared. 2 squared. Which is same thing as 1 over S minus S over S squared plus 4. Therefore, the Laplace transform of 1 minus cos 2t over t will now be integral 0 to infinity according to the formula s to infinity f of s ds to give me s to infinity. This is our f of s, 1 over s minus s over s squared plus 4 ds. This is where they will now test the knowledge of our integration. We have 1 over s here minus. Remember, there's a formula which says that, the formula says, let me put it here, or let me get something here. The formula says this, where we have integral f prime of s over f of x ds. The answer is ln f of s. What that simply means is that if you have integration in terms of fraction, such that the numerator, the one on top, is just the differentiation of this denominator, then the answer is ln of that denominator. That is, if you can find the differentiation of this thing on top, the answer is ln of that denominator. You first find it here that if I differentiate s is 1, which is on top, I can get it here. But for this one, if I differentiate s squared, if I differentiate 4 is 0. If I differentiate s squared, what do I have? I have 2s. But what is there is x. In order to use the formula, I have to put 2 there. When I put 2 there, I'll put half here too, so that if 2 cancel 2, we'll still be writing this. So that finally, our answer here will be ln s minus, this one is half ln s squared plus 4. I have integrated it like that. S to infinity. I can still play with the law of logarithm here. Let me first find the LCM. LCM is over 2. This is 2 ln s minus s squared plus 4. 0 to infinity. Let us bring this half out. According to law of this is s to infinity. According to law of logarithm, these two can come to the front. But if it comes to the front, it becomes squared minus this s to infinity. Remember, according to law of logarithm, this minus comes to becomes division. So we have this over this. Infinity and s. Now if you put this to be infinity, we have to find the limit. We are putting s to be infinity. You cannot put infinity like that. You need to find the limit. And if you recall, how we normally find limit to infinity in differentiation, we divide both sides by s squared. So this is s squared divided by s squared over s squared divided by s squared plus 4 divided by s squared. That is for infinity. Then normally we put s to s. That one does not change anything. Minus, you put s to s. Limit s squared plus 4. So this will give me half into, this is ln 1 over 1 plus 4 over s squared. Remember, we are putting s tends to infinity. S tends to infinity. Minus ln s squared over s squared plus 4. Now, as s tends to infinity, this one will become 0. 4 over infinity is 0. Then, minus ln s squared over s squared plus 4. So, it will remain 1 here. Ln 1 or log 1 is 0. So, what we have is minus. This one is 0 already. What we have left will be half into minus ln s squared over s squared plus 4. Which is same thing as minus half ln s squared over s squared plus 4. And you can decide to bring this one to the front. If you can decide to bring this minus to the front, you can still have it to be s squared plus 4 over s squared. The minus will interchange these two. So this is our answer, or this one. Any of the two is our answer. Practice these questions. Pause and write it. So have a nice day.